Question 6 is the sort of locus question, accurate scale drawing. So I've drawn it roughly accurately. It won't look perfect on here because it'll depend on where you're at, but the scale of 1 centimetre to 2 kilometres, so that might be worth writing down here. And the new shopping centre is going to be built. The shopping centre will be less than 12 kilometres from Middleton. So first thing we're going to do is get a ruler and a compass, and it's going to be 12. Now we're not going to measure 12 here because it's scaled, so it's 1 centimetre every 2 kilometres. So if you divide 12 by 2, that means it's going to be 6 centimetres long. So we go along to Middleton and we then draw out where that 6 centimetres will be. Now we'll then also do it on the other side, but this is now 15, so we're going to be looking at 7.5. Now what I'm just going to do is just slightly change the size of the question. I'm not sure I'm going to get an answer here if I'm not careful. So I'll just quickly remove that bit. So we'll just redraw that bit out again, so that goes in there. And then we've got from Newtown, it's less than 15 kilometres. So straighten out the compass again. 15 means 7.5. So we go to Newtown, spin it round, and again we mark the arc in. So where can it be then? Well, the shopping centre then will be in the area between the two arcs, so down here. Question 7. Make T the subject of this formula. So question 7 here, just get rid of this. So question 7, T the subject, so we've got 3t plus b equals a squared. So we've got to work out t. We're going to not work out t, but we'll put t on its own. So the first thing I'm going to do is move the b over. So take b from both sides. So I'll get a squared minus b, and divide by 3. So that will give me t equals a squared minus b, all divided by 3, and that's changing the subject. Question 8, work out the volume of this prism. Well, what I'm going to do is I'm going to take the 8 eventually. I'm going to work out the area of this front face first, and then times it by 8, because in effect there's got like 8 cuttings. I could cut these into 8 pieces. There'd be 8 of them going backwards, and this will be the first front. So the way I'm going to do this is split it into possibly 3 shapes actually. You can make it a square if you want first, and then take off a triangle, but I'm going to split it into 3 shapes here, and then just write down the different values that I've got. So I've got 15 here. This is 7, so 7 will go in there, and that's going to be 5. So I'm just going to give it my 12 there. If that's 5 up, and we know that's 15, well, this is going to be 5 here, and that's going to be 10 in there. And we also know we've got a 5 in there. So to work out the area of the front, I've got 15 times 7. I've got 5 times 5. And I've got 5 times 10 halved because it's a triangle. So 15 times 7, first of all, is 105. 5 5s are 25. 5 10s are 50, halved is 25. So add all these together, that gives me 155. So I know that's in centimetres squared because the area of the front of this shape here. And then we take 155 and times it by 8, which will then give me the overall volume, which is then 1240 centimetres cubed. That's question 8 then ticked off. Question 9. So, running track, region the shape. The region is in the shape of a rectangle and a semicircle both ends. The rectangle has a length this and blah 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 blah. The groundsman is to cover this region with grass seed. 1 sack of grass seed will cover 250 metres squared. How many sacks of grass seed does the groundsman need? Right, well again we're going to split this into different shapes. What we can actually do here is, if we actually work this out at this point and this point, then you've got the rectangle, and you've also then got a circle if you join your 2 semicircles together. So our rectangle is 64 times 105. gives us 6,720 metres squared. And then we've got the area of the circle, and that's pi times r squared. So it's pi times the radius, and the radius is half the diameter, so it's 32 squared. So 32 squared first, getting equals, times that by pi. That gives you 3,116.99. Add these two together then. Which then gives you 9,936.99 centimetres squared. And then divide that by 250. Which then gives you 39.7 bags. So that'll round up because you need to definitely have enough to 40 bags required for question 9. Question 10, we've got a trial and improvement question here. Oops, sorry, add a slide in there, that's question 11. So, question 10 here, we're going to be looking at this equation here. It's quite a tough equation to sub into. We know it's between 6 and 7. Find the solution between to one decimal place between these values. So the first value you're going to try is 6.5. Now this means 6.5 cubed, and then it would be 6.5 squared times 6 and add it on. So what I'll do is I'll put them in brackets in the calculator. So I'll just show you how I'll write it in the calculator first, this first one. I'd write that, I'd put 6 and then 6.5 squared. So we get 528.125, and that's too big. So I'm going to try a smaller one. So I'll try 6.3 this time. Now I can only, on my calculator, just delete the 5s and put 3s in. It saves a lot of rekeying. And that gives me 488.187, which is too small. So then I'm going to try x equals 6.4. That gives you 507.904, which is too big. Now some people then just go, okay, straight away, oh yeah, it's got to be 6.4 because it's closer. You can't do that. You've got to take a value in between the two values you think it is. And when you've done that, then you are able to definitely say which value it is. Now that's 497.982. Now that's too small. So therefore we look at this, it's just too small, so therefore it's the one above it. So therefore x will equal 6.4 to 1 dp.